All right, let's dive right in. Today, we're tackling question 1 from the June 2024 AQA GCSE Chemistry paper. But here's the twist. We're not just going to solve it. Oh no, we're going to pull back the curtain and look at the official mark scheme. This is all about learning to think like an examiner, so you know exactly where every single one of those marks comes from.
So, here's how we're going to do this. First, we'll look at the exam challenge itself. Then, we'll complete the equation, get into the nitty-gritty of the experiment, nail that percentage yield calculation, and finish up by picking the right metal. By the end, you'll have the secrets of the mark scheme totally unlocked. Ready? Let's go.
Okay, so let's set the scene. We're looking at a super common experiment, a real classic. A student is making a salt. You've probably done something like this yourself. The whole point of a question like this is to see if you really get what's happening, not just the chemistry, but the how-to of the practical as well.
Now look here, the question gives you the entire method, step by step, from measuring the acid all the way to getting those crystals. Seriously, whatever you do, don't just skim this part. This is your foundation. Reading this and actually understanding it is the absolute first step. Every single mark we're about to hunt down, it all starts right here.
All right, let's jump into the first part. Question 01.1. It's a 2-marker and it gets right to the heart of the reaction. All you got to do is complete a word equation.
So we've got copper carbonate reacting with sulfuric acid. The question tells us one product is carbon dioxide. But what about the other two? Come on, you know this rule, right? Metal carbonate plus acid gives you 3 things: a salt, water, and carbon dioxide. So think about it for a second. What's the specific salt we're making in this reaction?
And boom! Here are the answers, straight from the examiner's playbook. You get 1 mark for copper sulfate and another mark for water. Simple as that. But hey, check out that little note in the brackets. This is a great tip. The mark scheme says you can totally write the chemical formulas, CSO4 and H2O, and still bag both marks. See? Being precise really pays off.
Okay, let's move on. The next few questions are all about the nitty-gritty of the practical itself. This is where they test if you were paying attention in the lab, how things actually work.
Right, question 01.2. This one's all about using your eyes. How does the student actually know when they've added too much copper carbonate, when it's in excess? What's the visual clue that tells them, okay, stop, the reaction's finished? Picture that beaker in your mind. What would you see?
So the mark scheme actually gives 2 perfectly good answers here. First, you could say that you'd see some solid leftover at the bottom of the beaker. Makes sense, right? There's nothing left for it to react with. Or you could say the fizzing stops, no more bubbles. That tells you the gas isn't being produced anymore. And here's a pro tip, a real exam hack hidden in plain sight. Look at that examiner's note. They will ignore anything you write about colors. For this question, it's just not what they're looking for.
Okay, next question. Why does the student filter the mixture? This is a classic lab procedure, but they're looking for a very, very specific reason tied to what we've just been talking about.
And here it is. This is the kind of precision that gets you the mark. You have to say to remove the copper carbonate, or even better, to remove the excess copper carbonate. See, just saying something vague like to remove the solid probably isn't going to cut it. You've got to name that chemical.
All right, on to the next step, gentle warming. Question 01.4 wants you to name the right piece of kit for the job. So what do you use when you need gentle, controlled heat in a lab? What's it called?
The mark scheme is crystal clear on this one. You get the mark for saying electric heater or water bath. But just as important is what not to say. They will ignore Bunsen burner. And why is that? Well, a Bunsen flame is just way too hot and direct. You need gentle heat to slowly evaporate the water and get good crystals. A Bunsen is like using a sledgehammer to crack a nut here. Total overkill and a classic mistake.
Okay, deep breaths, everyone. Here comes the maths. Question 015, the big 3 marker. It's all about percentage yield. Don't panic. These questions are just a puzzle. They're designed to see if you can take an equation, move it around a bit, and work through the steps logically.
And look, the question is actually pretty helpful. It gives you all the pieces you need. You've got the formula, you've got the percentage yield, 92.8%, and you've got the maximum theoretical mass, which is 12.5 grams. So all you have to do is work backwards to find the actual mass the student made.
Now, here's how you get all 3 marks. The first one is for correctly rearranging the equation. That's mark number 1 right there. The second mark is for plugging the numbers in correctly. So showing that you're doing 92.8 divided by 100 and then multiplying by 12.5.
That gets you mark number 2. You absolutely have to show this step.
And finally, for the third and final mark, you get it for landing on the right answer, 11.6 grams. And remember, this is super important. Even if your final number is a bit off because you mashed the wrong button on your calculator, showing all your working means you can still scoop up those first 2 marks. Never, ever leave a calculation blank.
Okay, we're on the home stretch now. Let's look at the very last part, question 01.6. It's another 2-marker, and this time it's all about the reactivity series. You're going to need to give 2 different reasons for your answer.
So, the question is, why couldn't you just use copper metal or sodium metal to do this reaction with sulfuric acid? You need to explain why each one is a bad choice. And they're bad choices for completely different reasons. One reason for copper, one reason for sodium. And here's what the examiner is looking for. For copper, the answer is simple. It just doesn't react with sulfuric acid. It's too on-reactive. The mark scheme also says you could write it's below hydrogen in the reactivity series, and that's perfect too. Now for sodium, it's the complete opposite problem. The reason is safety. The mark scheme literally says it could explode. You could also get the mark for saying it gets too hot or that the reaction is just plain dangerous.
And that's it. We've completely picked apart question 1. But the real takeaway here isn't about copper carbonate. Not really. It's about a whole new way to look at every question you'll face, just by understanding how the mark scheme works.
Seriously, this is the most important thing to remember. A mark scheme isn't just an answer key. It's a blueprint for how to think like an examiner. If you can learn what they're looking for, you're halfway to acing the exam.
So let's wrap this up with a quick strategy guide. First, be precise. Use the right scientific words. Second, keep an eye out for those allow notes. They're your friends. They give you options. Third, know what not to write by checking the ignore notes. Fourth, for any calculation, no matter how simple, show your work. And finally, if they ask why, give them a proper scientific reason. That's the game plan.
So there you have it. You've officially seen behind the curtain. It's not just about knowing chemistry. It's about understanding the rules of the exam game. And now, you've got the tools. You know how to think like an examiner. So the real question is, what are you going to master next?